Solving a linear equation. So a little background first. Linear equations are equations where the variable is only to the first power. A lot of times they'll be in this form. mx plus b equals c, or something like that, where you've got an x term and some plain numbers. Or there might be x terms on both sides. But what they all have in common is that all the x's in the equations are just to the first power. So if you look at the two equations coming up, this one here, there's an x here, and it's just to the first power. This x and this x, they're just to the first power. So these are linear equations. So we have a list of steps that we're going to be working with as we solve linear equations. First, we're going to make sure we simplify and combine any like terms on each side. That is so important to simplify first, otherwise you just end up creating a lot of extra steps for yourself. Secondly, we're going to, well actually we can combine these two steps and just say we're going to work the equation backwards using the order of operations to undo everything until we have x alone. So if we look at the order of operations backwards, parentheses, exponents, multiplication or division, whichever comes first, and addition or subtraction. This is the order of operations now in reverse. So as we look at an equation, we're going to undo any addition or subtraction first, then any multiplication or division, then any exponents, and finally any parentheses. So order of operations backwards. So let's take a look at this first equation. It's an equation because it has an equal sign. I'm going to rewrite it bigger. What I want you to do when you're solving equations is create a wall. So when I tell you that both sides, to do the same thing to both sides of an equation, you know what I'm talking about when I say sides. Draw a little wall, a wavy line below the equal sign. Here's one side of our equation, here's the other side. The two sides of the equal sign. Now, I'm going to look at this side because it's busier. There's more going on. My goal eventually is to get x alone so that I find out what x equals. What one value of x can I put right here in the equation, times it by 3, and subtract 11 to give me 7. You could guess, and eventually you'd guess right because this one's not too terribly hard, but solving is usually much faster than guessing. So what are my solving steps? Undo any addition or subtraction on this side of the equation. I have subtraction right here. How do I undo minus 11? I do the opposite operation, which is addition. Addition and subtraction undo each other. So remember the balance scale idea? Whatever you do to one side of the equation to keep the scale balanced, you must do to the other side. And notice how I wrote plus 11 in front of both of them. Always write what you're doing in front of the number so that you remember and don't accidentally subtract when you should be adding or add when you're subtracting. So now if I look at the left side of my equation, this minus 11 plus 11 undo each other. They make 0 if you add them together. We don't write the 0 down, we're too lazy and it just gets in the way, but we bring down anything left on this side of the equation that we haven't dealt with yet. So we're going to bring down the 3x. Then, after performing the operation, we've got a new equation. So we write the equal sign on the wall, and we do the operation that we stated over here. It says to do 7 plus 11, and we get 18. Now my new equation, after rebalancing my scale, says 3 times some mystery number x gives me 18. Now you can figure out the answer to that in your head, can't you? 3 times what makes 18? Well, if I do 18 divided by 3, isn't that 6? Won't 3 times 6 equal 18? So at this point you could guess, but we do have equation solving steps that make sure we've got it right. After undoing any addition or subtraction, we undo any multiplication or division. Remember, there's an invisible times sign between 3 and x. I want to undo that so I get x alone. How do I undo 3 times x? Well, division undoes multiplication. So I divide both sides by 3. Wasn't that what we were going to do in our head anyway? 18 divided by 3 to give us 6. And over here, 3 divided by 3 is 1. It's 1x, but we're too lazy to write the 1, and I have my solution. I solved the equation, and I can check it. If I put 6 right here in the original equation and do 3 times 6, I get 18. Then I subtract 11, and 18 minus 11 is indeed 7. This is the one number in the world that makes the two sides of this equation equal. It's the solution. Now, before we go on to this somewhat difficult problem with fractions in it, I'm going to give you two simpler problems to practice first. So let's try this equation next. So this will be our example 2 for solving linear equations. Let's try 35 equals 6x minus 19. So somewhat similar to the first problem, but the busier side is on the right side of the equal sign, and we have subtraction instead of addition. First step, make sure if there's any like terms, you combine them. These are not alike. If there's any parentheses or anything like that, you simplify and get rid of them. But this equation is very simple. There's nothing to do before we start. Draw your wavy line down the equal sign so you create the wall and the two sides.